Okay, welcome back. Today we're going to work through a Unit 7 differential equations free response question A. I'm going to let you read the stem of the question, take a look at the slope field. The reason why the slope field is given as opposed to me asking you to provide the slope field is that there will be no graphs required on the 2020 exam. So part A asks us to find the value of k that makes the differential equation consistent with the slope field. Justify your answer. So we're going to jump right into it. We know that the derivative is 0 at any point xy where y equals 1. So I grabbed the point 1, 1 up here and noticed at 1, 1, so I'll jot this down here, at 1, 1, dy dx has a value of 0. So I'm going to take dy dx from up here, replace the dy dx with 0, 1/9 at a value of x equals 1 squared, cube root of k minus 1, and I'm going to use this to solve for k. So we have 0 equals 1/9 cube root of k minus 1, a little algebra here, multiply both sides by 9, you're left with 0, raise both sides to the third, and we get 0 equals k minus 1, so 1 is equal to k for part A. Part B, something that you will more than likely encounter with the differential equation question, is finding the equation of the line tangent to the graph of f of x at 3, 0. Use the tangent line to approximate the value of f of 2.9. Okay, so let's use our equation for dy dx, and let's plug in the point 3, 0. So again, I'm going to go up to refer to dy dx. So it is 1/9 x squared, so 3 squared, times the cube root of, we know k has a value of 1, so we're going to use 1 for k, 1 minus 0. So 1/9 times 9, and the cube root of 1. It comes out to be 1/9. Let me scoot up a little bit here. Of 9, which is 1, times the cube root of 1, which is also 1. So we get that the value of dy dx at the point 3, 0 is going to be 1. That is the slope of our tangent line. So what we have here, I'm just going to move over to the right here. What we have in point slope form is, or slope point form, y minus 0, which is the y coordinate, equals the slope 1, x minus the x coordinate. Y minus 0, so y equals x minus 3. It's the equation of the tangent line, and we're going to use that to approximate f of 2.9. So f of 2.9, approximately 2.9 minus 3. I'm just going to plug the x value into the tangent line, and that equals negative 0.1. Moving on to part C. Get into a couple of the longer parts here. Using the value of k from part A, remember k was equal to 1. Find the second derivative, so d squared y dx squared, and evaluate the second derivative at x equals 3. Based on this answer is the estimate for f of 2.9 from part B, an overestimate or an underestimate. So let's find the second derivative, and let's keep in mind that dy dx is equal to 1/9 x squared times the cube root of k minus y, and remember our value from k is 1, so 1 minus y. Now, while this refocuses, let's think about this. This is going to be a product rule question here. The reason why it's going to be a product rule question is we have 1/9 x squared as a function, and we have the cube root of 1 minus y as a function. So the derivative of the left-hand side, d squared y dx squared, equals the derivative of the first is 1/9 times 2x times the second, cube root of 1 minus y, plus the first, 1/9 x squared, times the derivative of the second, which would be 1 minus y to the 1/3. Use the power rule. 1/3 the quantity to the 1/3 minus 1, or negative 2/3, times the derivative of the inside, which would be negative dy dx. Okay, so we need to evaluate at, so d squared y dx squared, put a little parentheses after it because we're going to evaluate at let's see, evaluate at 3, 0 to get a value for the second derivative at that point, 3, 0. So we have 1/9. We're going to replace this x with a 3, so 1/9 of 6. We have the cube root of 1, 1/9 of 9, 3 squared, 1/3. 1 minus 0 is just 1 to the negative 2/3. Let's keep in mind that 1 to anything is going to be 1. And then negative dy dx, well, let's keep in mind that dy dx, the slope at 3, 0 from the previous question was just 1, so negative 1. So we have 6/9 or 2/3 times 1, so just 2/3. We have 1/9, and it's just going to become 1. And so 1, then we have 1 to anything here is going to be 1, so we just have a 1/3, and then we have a negative 1. So we have equals 2/3 minus a 1/3 is going to be equal to a 1/3. So that is the value of the second derivative at 3, because the point is 3, 0. And now this is going to be, so since the second derivative is positive, the function is concave up in some manner, which means the tangent line is below. So our estimate, which is on the tangent line, is going to be an underestimate. Underestimate. Because the graph of y equals f of x is concave up at x equals 3. So I squished that in there. Read it one more time. This is an underestimate because the graph of y equals f of x is concave up at x equals 3. The reason we know it's concave up is because the second derivative at the point 3, 0 has a value of 1/3, which is greater than 0. And remember, it did ask us to find the second derivative at 3. Last part for this question and the longest part. So let's get into it. We want to find the solution, and remember, I was going to say, they introduced a new function y equals g of x this time, and the reason they did is because they redefined k as 2. So y equals g of x is the solution of this differential. If we want a solution to a differential, we're going to have to integrate or find the antiderivative. And they give us a point on g as 3, 1. That's an initial condition. So let's get started with it. If we take this equation, dy dx, I'm going to move some things around. So I'm going to rewrite it as dy over the cube root of k minus y. But remember, k is equal to 2. So dy over the cube root of 2 minus y equals 1/9 x squared dx. That is my separation of variables step, more than likely worth a point on the exam. Find the antiderivative of both sides. So I'm going to rewrite this one as 2 minus y to the negative 1/3 dy. This one, I can find the antiderivative right away. It's 1/9. The antiderivative of x squared, using the power rule, is 1/3 x to the 3rd plus c. So on this side, it's 1/27 x to the 3rd plus c. Side is ready to go. We got some work on this side. I'm going to use substitution. U equals 2 minus y. Du is negative dy, and negative du is equal to dy. So rewrite this integral would be u to the negative 1/3. The dy becomes negative du. So if you notice, I put the negative on the outside. The antiderivative, add 1 to this, would be 2/3. Take the reciprocal as 3/2. U to the 2/3 with the negative out in front. And since we have the c on the right hand side, we don't need it on this side. So let's just go down here a little bit. Negative 3/2. I can just do this. Negative 3/2. And then u is 2 minus y raised to the 2/3 is equal to 1/27 x to the third plus c. Just like that. So that is our solution, a general solution to this differential. But what we're going to have to do is a couple more steps in here. We do have to plug in the initial condition, which would obviously be worth another point. So let's plug in the point 3, 1. So -3/2, 2 minus 1, because again I'm using this point that has a y-coordinate of 1. I think it's a good idea to plug in at this stage before we solve for y. So we have -3/2, 2 minus 1 to the 2/3 equals 1/27. X is 3 to the third plus c. So 2 minus 1 is 1. 1 to any power is 1. So this side is -3/2. 3 to the third is 27. 1/27 of 27 is 1. Subtract 1 from both sides, and we get a c value of -5/2. Okay, last couple parts of the question here. I'm going to plug c back into my general solution from this step. -3/2, 2 minus y to the 2/3 equals 1/27 x to the third plus c. Now for the sake of time, I'm just going to divide both sides by the -3/2, and my c is -5/2. Let me put that in. My fault. That was the whole point of the last step. So c is -5/2. So I'm going to divide both sides by -3/2 and then raise both sides to the 3/2. So I get 2 minus y, 1/27 x to the third minus 5/2 divided by this -3/2 from here. And then to get rid of the 2/3, I'm going to raise both sides to the 3/2. 3/2. I'm going to subtract 2 and multiply everything by negative. So if I subtract 2 from both sides, I'm going to have a -2 on this side. It's become positive. And then this is going to be a negative, this quantity right here. So I know I ran through this last part quickly, a little bit of messy algebra, but this is what we call our particular solution. This is what we call our general solution. You're going to get points all along the way. More than likely a problem of this nature, or part of a problem of this nature, is with 4 or 5 points. So get as far as you can.